Welcome to the 5th annual LaunchCMU. This year's theme is Robotics in Manufacturing. LaunchCMU has been made possible by Latham and Watkins, and our founding sponsors, Patrick Poland and Ben Potter, here in the front. If you raise your hand, guys, to say hi to everybody. They took a flyer on us 5 years ago when we had created the Center for Innovation and Entrepreneurship, which has become the Schwartz Center. And this event has grown and grown every year. We do it once in Silicon Valley in the spring, here in the fall at Pittsburgh, and we're hoping to add New York City in the not too distant future. My name is Dave Mowini. I'm the Executive Director of the Schwartz Center and an Associate Teaching Professor of Entrepreneurship in the Tepper School of Business, along with faculty directors Lenore Blum from the School of Computer Science and John Kagan from CIT, the College of Engineering. John, I know you're here somewhere. Raise your hand. There he is in the middle. Thank you. We are the leadership team for the Schwartz Center. The Schwartz Center for Entrepreneurship was launched at this event last year, thanks to a transformational $31 million gift from Jim Schwartz, the founder of Accel Partners. This has enabled what we're doing. And last year we showed this video to explain what we would do at the Schwartz Center. So I'd like to play that again. I know there's a lot of new people in the crowd that may be wondering, what is the Schwartz Center? How does it operate? So this video should give you an idea.
Opportunity. It's out there. Through creativity, hard work, and soaring above the norm, you can seize it. You are an entrepreneur. Whether you're an undergrad, a graduate student, an alumnus, or a faculty member. The Schwartz Center for Entrepreneurship at Carnegie Mellon University is your opportunity, your path to success, where you bring your ideas to market. Courses for credit at Carnegie Mellon are at the core of the ecosystem, supported by countless extracurricular programs, global resources, and networks that launch companies. Entrepreneurs jump into the Schwartz Center ecosystem at any time to build a unique path and collide with ideas, creativity, and visionaries also striving for success. Consider a student. While attending Entrepreneurship Bootcamp, he learns about the Schwartz Center Incubator, Project Olympus, giving him the opportunity to earn a Spark grant, which provides the capital needed to launch his startup. He then becomes a Schwartz Fellow, a cohort program for entrepreneur training. Or a faculty member who, through the National Science Foundation I-Corps program, discovers how to commercialize her research, which then gains recognition at LaunchCMU, the Schwartz Center's public entrepreneur showcase of student, alumni, faculty, and staff. At the same time, her PhD student earns additional funding by winning the McGinnis Venture Competition for CMU students and becomes an Innovation Fellow. An alum takes full advantage of the Schwartz Center Connects workshops and gets mentoring from the entrepreneur in residence who suggests joining the I-Corps Site program. During this program, the alum learns about the Open Field Entrepreneurs Fund, which provides seed funding to recent alumni. For every entrepreneur, every research project, every business idea, our centralized ecosystem creates unique paths to learn, network, commercialize, invest, and launch the next great startup.
The Schwartz Center is a great place because with all the resources at Carnegie Mellon, it's all being put under one roof, and that's amazing.
The quality programs at Carnegie Mellon, it's the people, it's the fact they interact with each other, it's the fact that there is this more community spirit here that's really important and really helpful in starting businesses.
Students and faculty are really able to come together and share their thoughts and opinions and experiences regarding entrepreneurship. Different seminars that were free and open to anyone on campus was incredibly helpful to me.
Everybody has an extracurricular activity that they enjoy and that they're really passionate about, and they sort of combine their passion with their major, and that is exactly what is necessary to be a successful entrepreneur.
The Schwartz Center for Entrepreneurship at Carnegie Mellon University.
Let me close this tab off so it doesn't launch another video. Oh, there we go. I am tech disabled. I used to be a CTO. Can you believe that? Great. Thank you, Aaron. I appreciate that. Aaron is one of our staff members at the Schwartz Center. I know Allison, Sonia, Melanie, Kit. Are you all here? Could you stand up so everybody can see members of the Schwartz Center team? Great. Awesome. Our EIRs, Rob Meyer, Will Kegler, Craig Markovitz, Kit Needham there as well. These are all members of the team, and these are people that you can seek out that can help you understand what it is we do and help you with your startup. We do have 3 goals and missions at the Schwartz Center for Entrepreneurship. The first is to make CMU the destination of choice for aspiring entrepreneurs. We're always in the top 10 of the rankings that are out there for entrepreneurship, but we really want to be the best. We want to be seen in the same breath with MIT and Stanford. Our second goal is to create winning ventures. This is the most important goal to Jim Schwartz. I always use the joke, Stanford has Google, Harvard has Facebook, Carnegie Mellon has, my new joke is Lending Home. Where are you, Matt Humphrey? It's his startup. But the idea is that if we can create that company that everybody associates with Carnegie Mellon, we can take things to the next level. And if we do that, we'll create dozens and dozens and dozens of very valuable companies that create great jobs in the communities that they serve. And then finally, to make this all happen, we have to activate our 100,000 strong living alumni all over the world. The way that I put this into layman's terms is every one of our alumni should be a customer or a supplier or a mentor or an investor in each other's startups. That's really, really important. And we need all of those that you are alums or community partners here. That's important to us. So all of the program that we talked about in the video that we do has to map back to one or more of these goals, and it has to serve one or more of the 6 different customer segments that we have for the Schwartz Center. Undergraduate students, professional masters, PhDs and postdocs, faculty and staff, alumni, and community members, partners. So everything we do is for those folks. To get started today, I would have the great pleasure to introduce Lori Weingart, the provost for Carnegie Mellon University. Lori is also the Richard M. and Margaret S. Syatt Professor of Organizational Behavior and Theory in the Tepper School of Business. Lori has been a great proponent of entrepreneurship at CMU. She actually co-founded the Tepper Entrepreneurship Capstone course, Designing and Leading a Business. So it's with great pleasure that I welcome Lori Weingart to the stage.
Well, hi, everyone. It's great to be here. Thanks, Dave, for that kind introduction, and a warm welcome to everyone gathered here to celebrate the first anniversary of the launch of the Schwartz Center of Entrepreneurship. As you know, the Schwartz Center was made by a generous gift, made possible by a generous gift from Jim Schwartz. Now, since its doors opened last year, and I'll say opened with air quotes because we know these activities have been going on for a long time, but now the Schwartz Center is really becoming a hub for campus-wide entrepreneurial activities. That's the umbrella. Just in the past year, the center has launched the Entrepreneur in Residence program, partnered with the College of Engineering for the Venture Bridge program at CMU Silicon Valley, and that leverages our Bay Area campus to connect entrepreneurs with area investors and alumni. And we've continued to expand our academic programs, including an interdisciplinary minor for undergraduates in innovation and entrepreneurship, a new course sequence for MBA students on entrepreneurship through acquisition, and bicoastal majors in technology ventures, among other achievements. So there's a lot going on. It's very energizing. I also want to acknowledge the exceptional leadership team that we have at the helm of the Schwartz Center, including, as we've heard, Dave Mawhinney, its executive director, Lenore Blum and John Kagan, the 2 faculty directors. And I'd like to acknowledge our academic leaders, Bob Damion, the dean of the Tepper School, Andrew Moore, the dean of the College of Computer Science, and Jim Garrett, the dean of the College of Engineering. So please join me in congratulating all of them. Finally, I'd like to welcome Matt Humphreys and Peter Stern, 2 of the members of the Schwartz Center Advisory Board. So this advisory board consists of 12 successful entrepreneurs with connections to Carnegie Mellon. We thank them for their willingness to provide their counsel and their passion for enhancing the culture of entrepreneurship here at Carnegie Mellon. So I think you're here, yes? There we go. So thank you. Now, entrepreneurship is certainly flourishing here at Carnegie Mellon. I think we all know that. But it's not a new idea. Like CMU companies have raised more than $1 billion in capital and launched over 260 startups since 2008. Now tonight you're going to get a chance to hear from some of the top talent during our panel on robotics and manufacturing, and each has a very significant relationship with Carnegie Mellon. So we have the Advanced Robotics for Manufacturing Institute, HEBI Robotics, IM Robotics, Agility Robotics, Titan Robotics, and RoBotany. So I think we have to work on the naming of, we know it's robotics. Okay, the partnerships we have with organizations like these, Department of Defense and others, are what continue to feed the innovation ecosystem at Carnegie Mellon. So we need partners who are passionate about what our students do, what our startups can do for our community, for our nation, and for our world. And it's bigger than the bottom line. Startups from Carnegie Mellon are often looking at how we can use technology to improve the quality of life. For example, you've heard about Blue Belt Technologies, which has developed a surgical system for knee replacements with robotics-assisted technology. You hear about Duolingo, a language learning platform that allows us to expand our world by learning languages at no cost. For Moms develops robotics baby gear that's known for helping parents meet their needs of children, ranging from newborns to preschoolers. So we're familiar with those companies, and now we have a whole new set that are continuing to energize the activities. So the Schwartz Center itself ensures that CMU's strengths in entrepreneurship, technology transfer, and economic development continue to provide that vital bridge from research to practice. And so it's a process, there's a pathway, right? We have cross-disciplinary courses and degrees, networking and funding opportunities for students and faculty, mentoring through the Entrepreneur in Residence program, experiential programs that take students out of the classroom and starting their own companies, and Project Olympus, the premier incubator of the Schwartz Center, which has helped over 130 companies get off the ground since 2007. So taken together, these programs, resources, and opportunities really accelerate the promising research that we have at Carnegie Mellon and nurture groundbreaking ideas from inception to launch. So as you enjoy the presentations tonight during LaunchCMU, know that they represent only a handful of the exciting developments happening here on campus each and every day. So now it's my pleasure to introduce Ben Potter to the stage. Ben is a partner in the Silicon Valley office of Latham & Watkins. He's the co-chair of both the firm's technology industry group as well as the firm's internet and digital media industry groups. Ben represents emerging companies, venture capital and private equity firms, and investment banks involved in technology, life sciences, and clean tech industries. So his practice focuses on general corporate counseling, venture capital financing, mergers and acquisitions, and public offerings. Certainly he's somebody you want to know. So please join me in welcoming Ben to the stage.
Great. As I was introduced, my name is Ben Potter. I'm a partner in Latham & Watkins in Silicon Valley, co-chair of our technology practice worldwide. We are so pleased and very proud to be a sponsor of LaunchCMU again for the 5th consecutive year. As Dave described earlier, my partner and boss, Patrick, who's sitting in the front row there, spent the day today with CMU faculty and graduate students teaching workshops based on legal considerations in founding and scaling startups. Patrick and I always look forward to our visits to Pittsburgh. Latham is a global firm with 2,400 lawyers worldwide, and this affords us opportunities to meet with entrepreneurs and investors from a wide variety of sectors and geographies. But in Pittsburgh, we're always particularly struck by the intelligence, poise, quiet confidence, pragmatism, and ingenuity of the people we meet and interact with here. The trip also gives us a chance to reconnect with friends and contacts at talented firms and people we've been fortunate to work with over the years. Patrick and I spend a lot of time helping founders start and grow private and public companies. But he and I also spend a lot of time focusing, planning, and innovating on ways we can advise our clients more effectively. That is, raise the bar on the quality of service we provide to higher and higher levels. I recently read a book by the late Bill Walsh, former coach and GM of the San Francisco 49ers, titled The Score Takes Care of Itself. For those of you who don't know, Mr. Walsh was perhaps the greatest NFL coach of all time. I was inspired to read the book because I watched a keynote address that Jack Dorsey of Twitter and Square delivered at Y Combinator a few years ago, in which he actually just read from the book at length. Many of the passages he read resonated with me very deeply because Walsh writes about how to teach, ingrain, and perpetuate what he calls the capital S standard of performance, capital P, in an organization. Firms that learn how to do this, he writes, the score will take care of itself. So I thought I'd copycat both Jack Dorsey and Bill Walsh and read one passage from that book with the hope that it'll speak to people in the room as it spoke to me. The passage is called Establishing Your Standard of Performance. In quantifying and implementing your own vision of the standard of performance, the following guidelines are a good reference point. Number one, start with a comprehensive recognition of, reverence for, and identification of the specific actions and attitudes relevant to your team's performance in production. Two, be clarion clear in communicating your expectation of high effort and execution of your standard of performance. Like water, many decent individuals will seek lower ground if left to their own inclinations. In most cases, you are the one who inspires and demands they go upward rather than settle for the comfort of doing what comes easily. Push them beyond their comfort zone. Expect them to give the extra effort. Number three, let all know that you expect them to possess the highest level of expertise in the area of responsibility. Number four, beyond standards and methodology, teach your beliefs, your values, your philosophy. An organization is not an inanimate object. It's a living organism you must nurture, guide, and strengthen. Number five, teach connection and extension. An organization filled with individuals who are, quote, independent contractors, unattached to one another, is a team with little interior cohesion and strength. And six, make the expectations and metrics of competence you demand in actions and attitudes from personnel the new reality of your organization. You must provide the model for your new standard in your actions and your attitude. And with that, on behalf of the entire Latham team, I'd like to thank you all again for being here today, and thank you for the honor to sponsor such an important and great event. Thank you.
As I said before, we literally couldn't do this event without the sponsorship of Latham & Watkins. We're very, very grateful for their support over time. Pat and Ben have become great friends. They've represented some great Carnegie Mellon companies like Duolingo, Solvi, which is an artificial intelligence company started by two PhDs in computer scientists, and they were signing up their next new client today, Nimbus Robotics. So thank you guys. I'd be remiss if I didn't say that a Pittsburgh guy made Bill Walsh the greatest coach of all time, right? And so that was Joe Montana, for those of you who don't know. But they obviously did a great job together. I'd like to move on now to our showcase speakers in the main part of our program, robotics in manufacturing. Our first speaker is Gary Feder. Gary Feder is a great guy. I've known him in all my time here at Carnegie Mellon. He is the interim CEO of the Advanced Robotics for Manufacturing Institute. It was newly formed at the beginning of this year. He is the Howard M. Wilkoff Professor of Electrical and Computer Engineering, and he's a professor of the Robotics Institute. So please join me in welcoming the former Vice Provost of Research at Carnegie Mellon, Gary Feder.
Thank you. And good morning, Carnegie Mellon entrepreneurs. And I'm waiting for a good morning, a good afternoon. Good afternoon, Carnegie Mellon entrepreneurs. Nice to see you all. I'm really pleased to be here, and I want to thank Dave and Lenore and John for putting this event together and for inviting me to come up and say a few words. I'm thrilled to be kicking off what looks to be a great lineup of these robotics companies. I am the CEO of what's called the ARM Institute, the Advanced Robotics for Manufacturing Institute. It got started just this year. We're very excited about this. This is housed in Pittsburgh, and it's an institute that got created due to a lot of hard work by a lot of people at Carnegie Mellon, and led by Howie Choset, who you're going to hear from next about a different enterprise that he's involved with, and myself. And we got started on this January of this year. It's housed right now at NREC, and which is the National Robotics Engineering Center in Lawrenceville, which also houses some of the other small startup robotics companies in the region. And one way to think of us is, you might be a little envious, but I'll tell you maybe later why you might not be that envious of us, but we are a startup effectively with an $80 million venture fund from the federal government. I guess the reason not to be envious of us, it means that the federal government certainly works with us they're the government to help. So we have a very focused mission. That mission is to be ultimately the leading accelerator for robotics and automation in the U.S. For fueling growth both of jobs and also of our competitiveness in the world. We've got a few strategies to do this, and this really does tie in with the startup community here. So it is relevant, it should be relevant to all of you as well. We've got three key pillars that we work on in the Institute. One is to build the network across sectors in robotics so that it's a consortium-based organization. So we're pulling together folks from across that ecosystem who are going to come together and maybe not otherwise rub shoulders with each other. So these are folks that could be from the defense industry, it could be logistics suppliers like Walmart and Amazon, and robotics companies, of course, that are traditional ones like ABB, along with small companies, community colleges, universities, and so on. So we're building that ecosystem, and then we're fueling this with our mission to be able to accelerate technology and workforce development. We're accelerating this with focused investments in technology projects and in workforce development projects. We'll have our first couple project calls out actually next Monday. So they'll be out on the streets for people for our members to stew over. And the goal is really to bridge the gap between the types of applied research outcomes, a lot of which you see that are embryonic, and be able to harden them into products that can be commercialized and be commercialized en masse. And we do that, of course, our focus is on the robotics part of the manufacturing. You might ask, where is our focus in technology? Howie Choset, our CTO, has been working with our members on road mapping in this process, and we've come up with 4 primary attributes and a 5th one that we think is very important in the future. These are, of course, lowering costs for robotics, being able to rapidly deploy them, making them versatile, meaning that we put robots in the field and normally they're used for one thing and that's it, and we want to be able to create technologies where robots can then be repurposed afterward, and then make them collaborative with themselves, collaborative with other workers. And then the last one I put in parentheses is being cyber secure. This is an area that we're all now, I think everyone in the IT space, in businesses are concerned about cybersecurity. We also should be concerned about that in our robotics platforms that we're putting out, whether they be through startups or large companies. And then we're looking to move this to solve technology gaps in these various areas. And these are the typical types of gaps you'd see in robotics, in interaction with humans and robots, scheduling, perception, mobility, and so on, along with things like evaluation. And then apply them to various application sectors. These are some of the primary ones that we work in. Even the area that may not be as obvious in food and beverage is one of the largest sectors in manufacturing in the world, and it's really ripe for robotics and automation. So I think I saw the automated dishwashing. We move back up the food chain, and let's start automating more of the food business as well. I think this is an area where there could be quite a bit of startup activity. Another area, I was mentioning collaborative robotics. This is an area that we feel very strongly about in terms of being able to grow this technology so that we can create jobs that not only get automated, but they provide a value add for the worker. We're very big proponents of, yes, we're going to have a future of work and changing workforce, but we're also going to have a great explosion of jobs in this particular sector, and we need to be ready for it. We also want to be able to develop the technologies, and some of you out there are probably working on these kinds of things, and we look forward to working with you as well in these areas. So kind of to wrap up, I'd say, what's in it for southwestern Pennsylvania? We're really set in this region to make a big difference. So while the ARM Institute is a nationwide nonprofit that is meant to, with a nationwide mission, we're also looking to make Pittsburgh and southwestern Pennsylvania be an enhanced test bed. It's already a test bed in robotics entrepreneurship. We want to make it an enhanced test bed in what we can do to expand the workforce, and expand productivity. We've got CMU and Pitt, great universities. We've got the startup community, a lot of them here. But we've also got small, medium manufacturers surrounding us that are looking, how do we pull them in with robotics and automation? And then, of course, we've got several large manufacturers. So in conclusion, with ARM, we're looking to solve a lot of the bottlenecks in these areas through our investments in the consortium networking, in workforce, and in technology to bridge the gap. We're looking to lower costs and access of robotics technologies, especially to small and medium businesses. We talked about collaborative robotics and workforce training. So we look forward to working with all of you. I will say that this is a consortium-based organization. We are open to membership, and if you're a small startup, you might be saying, well, I can't afford to be a member of the ARM Institute. And I guess the way we would reply to you is you can't afford not to be, because effectively there's a modest in-kind cost to being a member, but any startup that's actively in this space is going to get a huge return back on that with the various networking they're going to get out of it, and in engagement with the other membership. So with that, I will conclude, and appreciate you listening to me.
Is Howie Choset, as Gary said. Howie plays multiple roles here at the university. One of the roles that he's playing, though, outside the university is he's the TTO of the ARM Institute, but he's also a serial entrepreneur. I first got to know Howie probably about 10 or 15 years ago when he was starting a company called Medical Robotics, and you'll probably get a little bit of a history lesson on how HEBI is connected to medical robots. But today, Howie is here to speak about his really cool new startup, HEBI Robotics, where he's the CEO. So let's give Howie a great big hand.
Thanks for the introduction, and thank you, Dave and everyone else, for having us here. My name is Howie Choset, and I'm one of the co-founders of HEBI Robotics. HEBI Robotics is, our product are these robot modules that will accelerate the development of robot systems where we can make good robots almost as easy as if you're putting together Lego. Now, this is important, and it's an exciting time because the robotics business is exploding. We're finding service robotics, medical robotics, even robotics in the in industry is taking a new form in these so-called collaborative robotics that Gary mentioned earlier. And we believe that HEBI has the solution that will address all of these different areas. There we go. We're a spin-off from the Robotics Institute that came out of our lab, where we spent a lot of time developing these snake robots. like most robots, working with snake robots is very hard. And we field tested them a lot. We go out, we break them, we come back in, make them better. And in doing so, we figured that if we could make good modular components, that would accelerate the development of these systems as well as enhance their capabilities. So we developed this module and then very quickly realized we don't necessarily have to just build snake robots. We can build these legged systems. In fact, we can build these feeding systems. Larry Weidman from the Innovation Works, also another supporter of ours, challenged us to build this feeding system. And within 1 hour, Dave was here able to build, program, and eat lunch. What's pretty cool about these actuators, these motors, these modules, is that they can also sense force. They can feel force. So here, Dave is really quite safe, which is important for this future generation of collaborative robots where people and robots are going to be working closely together. With all those lessons learned, we now have this module. It's called the X series that the company is kind of defeats the point, that the company is currently commercializing, and we've been able to build, our customers have been able to build a variety of robot systems quite easily. Now, this is important, especially today, because as we see robots going into more and more areas, we need the ability to quickly customize our systems. One of the big fat lies in robotics is that robots are flexible. But that's not true. We normally adapt the process to the robot, not the robot to the process. Here, we can quickly we can quickly deploy robots that are customized for any kind of application using as few or as many modules, or in the robotics world, degrees of freedom that we need. Now, it's worth noting here, oh no, not there, next one. Here is one of our customers in Korea. They built a legged system to do inspection. And in this particular example, they were so happy with the robot, they actually used it on their TV commercials, selling whatever they sell. They were a power company. Another example is this company that built this self-driving car system. Oh, this is a Mac, and I don't know how to use it. If I hit enter, what will I do to make it play? Oh, there's the arrow. OK. It's not that important, but thank you. It's all right. What we have here is another one of our customers. They built a self-driving car using one of our actuators over here. So this car is driving, is Bob here, how fast, 30 miles an hour off-road? Yeah, about 30 miles an hour off-road. And it's pretty cool, because this guy's going real fast. And right now, what we're demonstrating, at first, what it seems like we're demonstrating is that we can retrofit existing legacy technology very easily and make them into robots. But I think the lesson here is even bigger. That module there, that steering, is not the hardest part of the system. The hardest part was this visualization, this localization, be able to stay on the road. What's great is that because of us, this is the easiest part of the system, being able to steer and drive this robot. And that's the value that we offer. We enable people to make good robots easily and quickly. Another example is this walking robot. We call it X-Monster. It's not a monster, but it's made of X modules. It's a 6-legged robot that's able to navigate all sorts of terrains to get to places where conventional robots otherwise can't access. I'm proud to say that there's a copy of this robot working round the clock in the Museum of Science and Industry in Chicago. So people there get to abuse the robot, drive it around, and it keeps on going. So I just want to close by pointing out the team that we have here. The people here, that's embarrassing. The irony is it's the timer that's telling me I have 2 minutes left. So I'm relaxed because I have plenty of time. So what's impressive about the team is that Carnegie Mellon attracted us. And in the Carnegie Mellon spirit, we're very multidisciplinary. We've come from all over the world, except for Bob. He's from Pittsburgh. He's our chief operations officer, so he's actually the responsible adult of the team. And we all have our strengths, disciplines, multidisciplinary, and in the Carnegie Mellon spirit, we're very much focused on making grounded systems go. What we were able to do was take it from the university out into the real world. And what makes me very happy about this is, of course, the ability to have an impact is always nice, but I really like working with these people. So at least for me, as a selfish professor, I get to keep my young just a little bit longer until they really conclude they don't need me anymore. But that's good, because that means I've graduated from this company, or the company's graduated from me, which is, I think, a great sign of success. I just want to introduce them very quickly. Florian is one of our software guys. Curtis, he was an undergraduate here and got his master's degree. Matt got his PhD in robotics. Dave also got his PhD in robotics. Bob got his MBA from Tepper, and I'm a faculty member here. So with that, I'm going to close, but if there's a minute for a question or two, I'm happy to take it as I walk off the stage. Or we can do the questions at the table afterwards. I thank you. Thanks. This is
Thank you,
yours.
Howie. Turns out that your video didn't work because you sent us a PDF. Okay, so. All right, our next speaker is Tom Galluzzo. I met Tom probably 5 or 6 years ago when he was an engineer and research scientist at the National Robotics Engineering Center, and was working on the predecessors of this technology. This is a really cool technology that does very pinpoint picking, and it's a revolutionary technology. So please welcome Tom Galluzzo, CEO and founder of IM Robotics.
There we go. Hi guys, I'm Tom Galluzzo. I'm the founder and CEO of IM Robotics. It's amazing to be here. Thank you to Dave and everyone at CMU for all the amazing work that you guys do. It's been 4 years since I left NREC. I was at the National Robotics Engineering Center here at CMU, and we left with a mission to automate everyday commerce. We want to see robots working everywhere in our daily lives. I often say to people, when you go out and about to Walmart or Starbucks, how many robots did you see? And the answer is probably 0. And we want to change that. And what I want to talk to you guys about today is why we think robots are so essential, autonomous robots are so essential to the future of our economy, and how we think that this is going to play out. So as we all know, digitization has changed society a lot, right? And particularly it's changing the way we live and we work. And what we find now is that people are really shifting away from manual work. Here we are at Carnegie Mellon, CMU, which I think should stand for Center of the Modern Universe, at least with respect to computer science and robotics and all these things that are changing industry. And so I want to talk about these digital transformations that are happening, a few pointed examples that we see. So the first one I think is key, the gig economy, right? And so we see ride sharing, 500,000, 500,000 new jobs have been created in just the past few years in a job category that previously didn't even exist on the planet, right? And so driving is an old skill. What's new is that obviously, we have these great mobile devices and technology, but it's the comfort level that people have, I would argue, with the technology that's allowed this particular application to be so embraced and take off so rapidly. And it's not just a comfort level in technology either. We are systematically educating people in STEM, science, technology, education, and math, right? So this is a great example, I think, particularly with respect to robotics, the first robotics competitions. Since this competition was started, or a set of competitions was started in the late 80s, we have now educated over 2 million folks in these kinds of hands-on robotics applications. How many students or anyone in the audience that was participated in FIRST or was a mentor or anything like that? Anyone, show of hands. So there's a lot of people, even in this room alone, that were involved with US FIRST. And that's 2 million people entering the workforce, primarily young folks, that are less interested in manual work, more interested in robotics and technology. So these people aren't really going to go into factory work or anything like that. They want to do jobs that involve technology. At the same time, we have 60 million baby boomers retiring. in the country right now. So that's 60 million folks that previously didn't have a lot of this exposure to science technology, that were doing a lot of the manual work, that are now leaving the workforce. So we got a lot of folks entering the workforce that have a lot of technological skill, and a lot of folks leaving the workforce that are taking the manual or the ability to do those manual jobs. So this is going to create a serious need for labor that we need to address. So I want to address the specific applications, and this is near and dear to our heart at IM Robotics, is retail and e-commerce in particular. So e-commerce is growing annually by 15% every year, right? At the same time, we have folks spending about 40 billion hours a year in the US shopping for consumer goods. And as you take more of that work out of the system, we're going to find very quickly that we don't have enough people to physically do the manual work to pick, pack, and ship our goods via e-commerce to us. So this chart kind of summarizes, this is data directly from the Bureau of Labor Statistics that shows that we have this exponentially growing need for work in the supply chain. At the same time, the young workforce willing to do that work is shrinking by a few percent per year. So we feel that this is the key area where robots, particularly autonomous robots, are going to fill the gap in the need for manual work and labor that has to take place, particularly in these kinds of jobs. So this is our robot. This is Swift. This is the world's first. We are the world's first company to deploy a robot with its own ability to travel and manipulate and see the world, to do the work that a person would do in the same infrastructure and the same task. So our robot uses computer vision, and we learned a lot about how to do this when we were here at Carnegie Mellon. Uses computer vision technology to see its way around, see the items that it's needs to grasp, physically grab them and transfer them so that people don't have to walk around the warehouse to do that work. So this is effectively a force multiplier. One person can manage 5 robots and be 5 times as productive as that one person would be otherwise if they had to physically do the work. So really what we see is that these autonomous robots are a new kind of tool, right? We think autonomous robots in particular are the third and final stage of the evolution of human tools. So at first, tools were physical things that were used to manually augment the work that a person could do. But people initially supplied the energy and the intelligence to use those tools. And we did that for thousands of generations, right? Then a few hundred years ago, a couple hundred years ago, a fundamental change happened, which is that the energy was now able to be supplied by the tools themselves, and that is what powered the Industrial Revolution. Now we're on the third and final paradigm shift in this, is that autonomous robots are going to be able to enter the workforce and the work that we do, and they're going to be able to provide the intelligence to the work that they do as well. So this is a key change because now we're able to really allow the machines to do more of the work that a person would otherwise have to do. And the key concern here, and we share this concern, is people are worried, well, what about people? What happens to us? What we're missing here is that, and you need to understand, is that people have special gifts, right? We have imagination, we have creativity, we have heart. And so we feel that what's going to happen is that as the machines do more and more of the physical work, people are going to be more empowered to do the kinds of work that only people are good at: social work, teaching, education, those kinds of things, which I think are imperative for our future. So really, IM Robotics and the work that we're doing, the work that we're doing in robotics in general, and at CMU here, is about sustainability. It's about being able to fill the gaps that we have for the labor that we need for the future, to drive a greater amount of productivity, and ultimately enable a better economy for all of us to live better lives. So I hope you enjoyed learning a little bit about IM Robotics today and what we're doing and the work we're doing. I am Tom Galluzzo, and we are IM Robotics. Thank you very much.
Thank you, Tom. Our next entrepreneur is Damion Shelton. Damion is a serial entrepreneur as well. I first met him when he had co-founded 3Reverse 3D with Mike Formica. He has a really cool new company. I think this has got some of the best eye candy on the stage today. It's called Agility Robotics. So let's welcome Damion Shelton.
Okay, so in the spirit of eye candy, I'll start with some eye candy. Okay, so that is Cassie, our first robot. I'd like to start with a thought experiment, which is how far is the last mile? The last mile is talked about a lot in logistics. And interestingly, we live in a time and in a town where saying something like, you can solve most of the last mile by just throwing a level 5 self-driving car at a problem is not a completely audacious statement. So really what's actually interesting from what is the unsolved science problem here and the unsolved market opportunity is not so much do self-driving cars exist, but once the self-driving car pulls up in front of your house and has to go the last 80 feet, how do you do that? And that is actually a pretty hard problem. That is moving through an unstructured human environment. There's not a lot of great solutions to it. Most of the market players that are trying to automate last mile delivery are focusing on the entire last mile and will sort of get into your backyard or on the curb in front of your house, but not actually up to your house proper. Pittsburgh is a particular issue with this. These are actually photographs of a sidewalk in Pittsburgh and then my co-founder Jonathan Hurst's house when he was a grad student. That was actually how they had to move a bandsaw out of his house for which he paid the princely sum of something like $50 for the movers to move it. I don't understand how you stay in business doing that. Anyway, what this suggests is that human mobility restrictions are actually a market limitation for deploying autonomy solutions. And why that matters is if we want to push robots out into human environments and outside of controlled environments like warehouse automation, although there is a large and robust market as we've seen for that, there is this whole untapped automation potential which is working out in the wider world. So this is our vision. We want to build mobility platforms that can address human environments. This is an enormous market. Just in the US, just for the US Postal Service and just the physical labor associated with that is a $20 billion a year market. And that is only looking at just the logistics and delivery services. Our approach is more versatile than wings, tracks, or wheels. So that is other approaches that people have had for last mile automation or for unstructured environment navigation. And Cassie's shown here and also in the initial video was our first product. That video was actually produced back in February. These are the commercial robots that we started selling to our launch customers in August. Why human dynamics matter and why we're pursuing legs as opposed to the myriad of other solutions are sort of encapsulated in one of Matt Mason's famous quotes at the RI, which is you can't program a rock to fly even if you have really great code. And why that matters is what that means is there are dynamics that are associated with the robot that are going to be behaviors that the robot exhibits, either good or bad. If you have a robot with infinitely stiff joints, like a lot of industrial actuators, you have to overcome the fact that there's this massive inertia, and you have to take these very sort of controlled walking movements. Cassie has a lot of compliance built into the limbs, so you can see physical springs to the back of the tie rods. This means that we can take really hard down steps and catch ourselves without having to actively control that behavior. It's a huge competitive advantage for us. We have great battery life. We can go all day on a single charge. We can go about 10 kilometers total range, and the robot is safe to be around. It weighs about what your lower body weighs by design. It's actually not a head. That's sort of about your belly button for reference, although it works as a head. So how do we get robots out the door to customers? There are 3 milestones, each of which yields a product that sells into a progressively larger market. We're at milestone 1 right now, working on milestone 2 actively. And the difference here is that we're viewing human mobility as the vertical market, of which there are interesting particular instances like delivery, but the market broadly construed is machines that can move around in human space. So milestone 1 is viable legs. This was Cassie watching the solar eclipse out in Oregon back in August. We didn't get a lot of comments from her because she doesn't have a mouth, but we think she enjoyed the experience. Our initial 3 launch customers were all research labs. We have another 3 research labs that we're selling into, one of which is actually a commercial entity. So far, so that'll be about $1.5 million of revenue this year just from robot sales. First customer deliveries completed back in September. For our next milestone, which we're calling self-sufficiency, this is a robot that we've tentatively codenamed Digit. We'll see if that sticks for the commercial release or not. It has arms, it has sensors for moving around the world. If it falls, it can get back up. It has a bunch of boring but necessary features like IP68, water and dust resistance, so that when it gets dirty, we can wash it down. No one will electrocute themselves working with the robot. We have our first customer already pre-committed for this. Commercial availability is not until 2019. And in this scale, we're operating at about $5 to $20 million a year revenue. We've already overshot our forecast for this year by a factor of 2, so it'll be exciting if we overshoot this forecast as well. And then the next big milestone, and this is the one that leads directly into the larger commercial distribution, is reliability at scale. And this is why I've sort of fuzzed out Digit here. It's going to be an evolution of Digit. It's not going to be exactly the Digit form factor per se. But this means hardening the robot and really starting to dig into what are the core requirements for larger application spaces like the last mile delivery platform. In this space, we start to compete competitively against the PackBot and Talon products for defense. So if you have a room that you don't know if there's a bad guy, you can walk the robot in rather than having to be restricted to the tank treads. We're actually already below the cost of goods sold target that we would have to be competitive in this market. And then from this point forwards, operating at scale is a matter of taking all the lessons that we've learned along the way of pushing out and supporting large, multi-hundred unit robot deployments in the field, and working with other partners who can provide, for example, self-driving vehicle services as part of a large fleet deployment to solve interesting problems like logistics. So where are we now? We've delivered 3 chassis to customers. We have 3 more in order that we're producing this fall. We have 9 employees, 6 of them are full-time, 2 other people starting in January. We have the exclusive license to the technology underlying chassis from Oregon State, and we're actually a DARPA contractor now on a sub-award, which is funding part of the work that's being done with the Digit robot. All of our manufacturing is actually done in Oregon, in-house. Most of the components for the robot are produced within a 100-mile radius of our office in Oregon. Okay, and then I'll just play a quick piece of this. The rest of this video is available on YouTube. This was shot in August, right before we got all the robots out the door to the customers. When these chassis walk around the corner, you'll see the initial prototype chassis with the carbon fiber shells crouched right there. Where we're at is about the cerebellum and down on level of intellectual complexity. So Cassie is right now being driven by remote control. We're adding higher level cognitive functions and AI capabilities. The input to the robot right now are commands like go forwards, turn left, and turn right. And we think that that kind of abstraction with legs is a huge market advantage. People have taken that kind of behavior for granted with wheeled and tracked platforms for years. And then so why are we so excited about platforms as opposed to soup to nuts robots? The example is this. This is a product that most people don't know exists. This is the Ford Transit platform. It has 2 instances that you may have seen on the road. One is a version where they take the core platform and add a passenger compartment and some leather and sell it for the vertical market of people transport. If you stick a dump truck bed on the back, it's a bulk material delivery van. We think Cassie or Cassie's successors are on the left, where there is a very light touch that you apply to differentiate for particular vertical markets, but the robot platform itself is what is unlocking the large market opportunities. And then to be completely audacious, we don't think we're at the Ford Transit Connect stage yet. We think we're here. Why we make this comparison is that it's not that there weren't other vehicles that were available for the Model T. What the Model T was known for was being affordable. We're the first bipedal robot that you can buy. We're the, right now, 2nd largest bipedal manufacturer in the world. Will be the largest in January. And we're excited to be exploring to see what can happen when bipedal robots are available to a broader market. Thanks.
Titan, it's got to be a big idea, right? Titan Robotics has spun out of RI and NREC as well, and Stuart's been working on this project for quite a few years now. So we're very excited to invite Stuart Lawrence, CEO and founder of Titan Robotics, to the stage.
All right, thank you, Dave, and thank you to everyone at the Entrepreneurship Center. We really appreciate the support you give to small companies like ours. It really makes a big difference. So we are a next-generation industrial robotics company. We're highly focused on aerospace automation. Aerospace is an industry that really hasn't benefited from robotics similar to what you see in the automotive industry, but they have increasing backlogs, thousands of aircraft, 7-year backlogs between Boeing, Airbus, and they're rapidly adopting automation to solve this because sometimes the orders for aircraft are based solely on the fact of who can produce it the fastest and when can I get it. We're also looking to leverage the work we're doing in aerospace automation towards general advanced manufacturing. A lot of the things I'll say are very much in line with what you heard from Gary, Howie, and Tom relative to robotics. We too are also from the National Robotics Engineering Center. We spun out about 2 years ago in December of 2015. That was after a 5-year program with the U.S. Air Force where we received about $24 million in R&D funding. During that time, there was a lot of interaction due to the foot traffic we get there with commercial industry that made us really think that this was a viable technology for a venture to go forward. So we exclusively licensed the IP from Carnegie Mellon, and I believe on the 24th of this month, we were notified that patent for our technology is going to be issued. So I said, we're the next generation of industrial robotics, and you hear a lot of buzzwords out there like Industry 4.0, Factory of the Future, the things that my engineers beat me up over when I say it. Like the infographic I have up here on display, it talks about cyber physical systems. But so what do we really do? Where do we fit into that space? We're talking about autonomy versus repeatability. There are a lot of robots deployed out there in the world that are really good at performing the same operation over and over, the same motions. They know what needs to be done to perform the process. What we're looking to do is give them job-level, instructions. Perform this process on this workpiece. You may not know exactly what motions need to be done, but you know enough about the process to be able to complete the task. And if not, we take a supervised autonomy approach where we have operators that are able to help answer some of the really tough questions. And how do we do this? It's for most autonomy systems, it's by employing software and sensors. So our focus in aerospace is mostly in the surface finishing applications where we're moving coatings from aircraft, surface preparation, painting is something that we're just getting into and performing inspections. There's a lot of costly touch labor associated with these processes, and that also impacts their inventories as well. At some point you'll have up to 26 workers performing one task on an aircraft. And having one more aircraft in their inventory is extremely costly. We work in very hazardous environments. These are not the type of jobs that are well suited for the human form. It's much better to have a robot in performing this work. So I'm going to see if I can get this video to play. Yes. So this is an example of coating removal that we worked on at the National Robotics Engineering Center. The robots before you were part of that program. Here, these robots are deployed at Hill Air Force Base. We're using a high-powered laser to selectively remove the coatings from the aircraft. As you can imagine, it was a bit of a challenge, not just for ourselves, but also for the Air Force, for this technology to be adopted, because most people are like, you're never touching my aircraft with a high-powered laser, are you crazy? But with lots of testing and we've gotten through the hurdles now that this system, along with our technology, has now been approved Air Force-wide for use on the substrates that are similar to legacy aircraft, not so much in some of the advanced composites that you see in like some of the 5th generation aircraft. It also lends itself well into the commercial space. We don't accept or expect that commercial airlines are going to readily adopt this technology, even though there's a lot of benefits to doing so, until the Air Force and the DoD have been using it for quite a while. Just to give you a little bit of understanding on some of the highlights there, employing this process yields about a 50% reduction in labor hours, a 30% reduction in cycle time. We have less fatigue damage using this process versus their current methods. And also from an environmental perspective, not only have we pulled the operators out of the hazardous environment where the chromates, these are very standard cancer-causing agents. We've moved them into the control booth, but we're also lessened the amount of hazardous waste that's generated from this process. So let's see here. So the past year, what we've been doing since we spun out of NREC, we've mostly been focused on the user experience, making it such that somebody with a high school education can go out and operate these advanced robotic systems. It took a lot of work going from our engineering interface that was developed by a lot of PhDs and high talent roboticists to get down to essentially these two live views where you have a 3D view that allows them to work throughout the space, inspect the aircraft, a bunch of overlays to give them information about the process that's going on, as well as the live view. And then here at the bottom, what we have is a little bit of information. I mentioned supervised autonomy. We pop up informational things of what should we do here? Should I continue to process? Is this somewhere where we should fire the laser? If not. So where we're going in advanced manufacturing, we need to expand our application portfolio. Like I said, mentioned earlier, we're doing a lot in the surface finishing space, but we need to get into machining, assembly, additive processes, and there's a lot of new processes where folks have approached us, things that we never even heard of, that they can't use a human to deploy these processes, but they're like, maybe your robot can, which has been opened up some exciting opportunities for us as well. And we hope, similar to HEBI, to be able to get into flexible manufacturing. We're not as reconfigurable. We're more reconfigurable at the end of arm tooling and at the production line level. But what we're trying to enable is on-demand production and make it feasible for low volume production, as well as scheduled robotic assets where you can share between production lines. I think we have some pretty heavy hitters when it comes to the robotics space, as well as a couple hustlers. We're a small team, about 8 full-time employees and a gaggle of part-time folks, but between us we have about 160 years combined robotic experience across all domains. So traction opportunities is probably the most important slide I have. So what we've been doing for our traction, we've been doing a lot of product support and R&D, advancing the technology, paying the bills. We've received about $2.5 million since beginning of 2016, which has been very helpful. But we want to grow, and that hasn't allowed us to grow. But we're finally at the point where we had hoped to be 2 years ago, where the opportunities have gotten to the point where we've crossed some of the adoption hurdles. Last week, we were just green-lighted for an aircraft coding system that we'll be doing for a full aircraft. We expect that mid-next year to get started. That's about $6 million. We also are being injected into a commercial aerospace program where we're providing our component technology, which is our software and our sensing. It's another robotic system. And with the approval across the Air Force for the laser process, we're looking by the end of next year, we should make our first sale for a different weapon system within the U.S. Air Force. So why I'm here today is how to get there. I have 9 months to prepare for some of those opportunities. We have to expand our staffing. We need new facilities, development assets, as well as to figure out financing. We've been very lucky where our customers to date have been willing to finance us, but that's not always going to be the case. We've been evaluating the options. I don't believe that we can continue with organic growth, or otherwise we're going to lose our competitive edge. So we're looking at a Series A or a strategic partnership. Also, we need to continue with our future growth for marketing, sales, building out that application portfolio, and exploring different business models. We thought MRO was going to be our big space that we were going to operate in. It turns out they can't afford these robots, so we have to find different ways to work with them. Hopefully, some of this, what I've said, has interested you. You can email me or pull me aside here today. I'd be happy to speak with anybody who would like to talk further. Thank you.
Okay, thank you for sticking with us. We're down to our last showcase speaker. This speaker is a little bit different than the ones that you've seen before. The first 4 companies came from research at the university level and have been spun out. This next company was developed by graduate students here at Carnegie Mellon. What they manufacture is food. So welcome Austin Webb, the CEO and founder of RoBotany.
Hey, can everyone hear me okay? Awesome. So as Dave mentioned, my name is Austin Webb, CEO and co-founder of RoBotany. And we are a robotic indoor vertical farming company. So to simply put it, we've created a fully integrated solution of robotic hardware and software. And to put it even more simply, we are growing plants indoors, produce indoors, with robots. And so some of you have seen this presentation before, many of you hopefully have not, but for the ones who have, I do have a few fun updates, so looking forward to sharing that with you. But to take a step back a little bit in terms of why we're doing this and how we got involved, it really comes down to the issues in traditional ag that exists today and the unsustainability of that endeavor. So traditional ag, as some of you may know, and hopefully a lot of you probably don't know, is that it's the #1 polluter of water, the #2 polluter of air, and the #1 user of fresh water on this planet. We're also beyond a breaking point when it comes to topsoil degradation. We have more runoff pollution and dead zones in the oceans than we've ever had before. And we actually are in an impending water crisis as well. When you think about the global population growing from 7 billion as it is today to 10 billion by 2050, with 80% of those folks, so 8 billion, living in urban cities, the current distribution situation is already stressed and will continue to get stressed, and we actually will have to produce more products than we have 8,000 years prior farming combined. So it's actually really staggering when you think about what the issues are. And so vertical farming is a really wonderful opportunity to solve this massive problem, because you can co-locate farms in urban cities, you can use significantly less water, you control the environment and you seal it off, and you can have a situation like we do at RoBotany and Pure Sky Farms, which is no herbicides or pesticides of any kind. And it's gotten a lot of traction over the recent year, basically, year and a half, but none of those articles have really touched on something that's a really core problem, and media outlets are starting to find it, and that is that the vertical farms that exist today, so all the farms that came out and essentially doing what we were doing without robotics, et cetera, that are older than us by 4 to 5, 6 years, are that they're really inefficient, right? They don't look at this as a manufacturing operation. We do. We view it as manufacturing living organisms. It's a situation where labor is the same amount as their energy costs, essentially. They waste over half their production space. Their form factors really lack true density in terms of a really important metric when it comes to production per 2D square foot, or and even just on a cubic foot basis. And really, they also lack a closed loop integration, both environmentally for themselves, as well as, more importantly, the tech. Okay, and so that's something where at RoBotany, we, very short range on this guy, is that we've created this fully integrated tech of hardware and software, right? So on the hardware side, we've created an autonomous storage and retrieval system. We've created a sanitation bot. We've created a harvest bot. We've created a proprietary solution of automated hardware that allows us to be more efficient from a labor standpoint, that allows us to have significant more density, very small hallways soon in the future, no hallways at all, to increase our density. And more importantly, something that the other farms really don't have at all is the brain behind that system, which is the software, right? And that is a really crucial part when we think about a number of things. So our farm is itself a robotic system. It monitors the farm real time, 24/7, 365. And the system itself, if it sees an issue in what it's monitoring, obviously it auto-corrects, right? It's not, pH levels start to want to get above 6.5, let's say, our system automatically doses pH down and keeps that right within the range that we want to keep it in. And beyond this, though, beyond this sort of real-time control, is the optimization factor. And this is definitely our compounding sustainable competitive advantage, and one that's really important for all of us in this room, because we're able to create with our system optimal grow recipes for every plant that we grow. So we can optimize for basically 4 really key variables, which is nutrient content, taste, and kind of along with taste, texture, and color, and then life cycle, so how quickly we can grow plants, and then the yield per plant. And so we're able to do all of this instead of focusing on what we have been focusing on for quite some time, which is the ability for plants to handle Roundup, pesticides, and other pest controls. And so that's a really exciting piece when we think about moving forward. RoBotany's system being able to create custom grows for restaurants, non-premium brands that are focused on life cycle and yield, something where, hey, maybe Bobby Flay is like, listen, Austin, I really want to have this specific, custom grow and brand in the grocery store, right? I mean, there's just a ton of opportunities of which we can tackle that, and it's important when it comes to those major issues I mentioned before. And so I'll sort of show you an old version, our very first hack system that we had, uncreatively, unlike Cassie and Digit, we could just call it version 1 prototype. But here it is, and it's going to start with a rendering of just some of the key principles. It's an old video and one we like because it kind of keeps us to our roots in terms of being lean startup. But essentially what you can see, and again, you'll see the real thing in a minute, and I'll show you some other iterations, is just that we're able to take trays and move them to new environment. So change the environment of that plant tray in the middle of its life to a different light spectrum situation, a different nutrient mix, a different nutrient schedule. We're able to yearly use that closed loop integration between our robotic hardware and the software in terms of creating the smart farm that is essentially operating itself and again optimizing for important variables. And so obviously this prototype was in Project Olympus, which is CMU's startup incubator. It basically fit inside a conference room and did a little under a pound a day. Allowed us to obviously start all of our testing when it comes to the tons of data and testing we need to collect for different light spectrums and nutrient mixes, et cetera. And obviously really proved our point at a miniature level of, hey, here's what we're going to do at scale. Basically, and this is just showing, hey, they're nice and green. So basically, we've now moved on to a former steel mill in the south side and created our version 2 mini farm. Again, lacking the creative names there. But this is a really important piece because this is our next step to which we created it's 2,000 square feet in the corner of our steel mill. It's 50,000 cubic feet because it's over 25 feet tall. This obviously is literally the miniature version of what we're about to do at scale. And I'm not showing all the fun things of the robotics, et cetera. And so I know that's kind of annoying that we do that, but we tend to be annoying on the IP side. But I think what's exciting to see is the differences in spectrums of full spectrum that we can do. And again, just proving our ability to operate this at scale. And so what all this means for us, jump back one, is that compared to the competition, right, we've tackled automation and analytics together in a closed loop system. Something where the other guys are sort of going to have to start doing a lot of one-off Band-Aids, et cetera, when they think about, so a lot of them are thinking about harvesting by itself, thinking about sanitation of trays, et cetera, by themselves. And that's something where we look at the entire process from seed to harvest as one process that's fully integrated. And from a metric standpoint, right, that means we can do over 180 times yields per 2D square foot compared to a traditional farm. That doesn't include crop loss, so it's a much higher number when you include crop loss that can really change depending on the farm. So it's even higher than that. And compared to other vertical farms, we have a significant advantage as well. And a lot of it just comes to increased density, increased harvest per year in terms of continuing to decrease that life cycle, and we can do it with better margins. And obviously food is the largest market in the world, so I don't have to tell you that, but I think the important thing I want to really hit right is the really important trends of which at RoBotany we are really hitting, right? And that is that across the board, no matter who you are, no matter what generation, it's about fresh, local, healthy food and wanting that access basically 24/7 all year round. And a lot of folks are really wanting to avoid chemicals, especially the younger millennial generation. And a lot of people are thinking who have families, they want to have better, safer food, because we have gone through quite a period of time where food is not nearly as healthy as it once was. And so that's something we're really tapping into, given what we're doing at RoBotany and our co-location of farms. So from a business model standpoint, we actually have a build and operate model. So instead of selling our robotics and sort of providing a turnkey solution to other folks, we are actually operating that technology ourselves and selling the produce. And so our brand is called Pure Sky Farms. And obviously with our version 2 farm that we had, we've significantly increased our distribution. So we're now going into the Whole Foods across all of Pittsburgh. We're also going to be launching in Giant Eagle Market District next month. And it's going to be really exciting because we'll be in both prepared foods as well as in the packaged area. But I think what's really exciting is the amount of traction that we've gotten inside the markets, and essentially this beyond organic, pure environment that creates healthier food, and you can get it in the grocery store the same day that we harvested it or the day after, is just amazing how much better the food is and how much better it is for you. And so by all means, I hope everyone goes out there and wants to purchase Pure Sky Farms in the grocery store. So hey, shameless plug, right? And so from an expansion standpoint, we're going to be looking to launch our first full-scale farm in the same steel mill I mentioned here in the coming months. So it'll be a 20,000 square foot farm. We'll do 2,000 pounds per day. And then we're really going to look to scale on top of that and start going through select cities in the US, then Canada. 5 years from now, We'd certainly like to have 20 farms. I think we can go much faster than that. But then obviously looking to hit other important markets such as China and Europe, the Middle East as well. There's a lot of urbanization that's occurring not just in the United States, but across the world with serious issues when it comes to food distribution. And then when we think about sort of the future as well, we're really excited about direct-to-consumer and direct-to-restaurant opportunities. And that's something where we're not going to be a transportation company, but let's say we partner with someone who's got automated freight that's integrated with Cassie, which Cassie will take our box of produce to the back door of the restaurant or to your front door. And so that's a very real future that we should be very excited about because it will happen, and we're excited to be a part of that. And so in terms of milestone next steps, as I mentioned, we've built a version 1 and version 2 prototype to date. We're just a little over a year old, raised $1 million to date. But again, more importantly, moving forward, launching that full-scale farm. And knock on wood, but we are in the next 24 to 48 hours looking to sign a term sheet for our Series A, and it's actually oversubscribed. So I think we'll have a little bit more than 10 million, which is really, really exciting. So we can move forward. Thanks. Thank you. So we can move forward on the next step of our plan. And so we're obviously at a big transition period at RoBotany, and we're really excited about that. And we're expanding our team beyond the 4 guys you see up here. But I do want to mention real quick for these guys, because I tend to do all the talking, that the other Austin, who's on the far left, is our CTO. He's a roboticist, and he grew up on a blueberry farm. My brother, who's a CIO, embedded systems software, IoT, he's incredibly smart in putting them together, Austin and Brack, in terms of a system design. And really, so that we're a hardware and software company at the same time is pretty amazing. And then Danny Syme, who was one of my classmates at Tepper, is really, really smart when thinking about operational engineering and operations. He has a 6 Sigma black belt, and he also naturally is an incredible builder. So in terms of how we tried to stay very lean and build it from the ground up, it's been a really important team, and these guys are amazing. And while we are techies, we also do have green thumbs. And so it's really exciting that we've been able to launch this product moving forward. And so with that, I just want to thank you all for your time. And I actually don't have a table, so I will be taking advantage of the food in there. So by all means, please definitely say hey to me where I'm at. Thank you.
Okay, well, thank you all very much. One final thank you to Latham & Watkins, our founding sponsor, and also to Oracle, who gives us a venue out in Silicon Valley when we hold the event there. Right now, we have the next hour and a half to tarry and talk amongst the 30-plus CMU startup companies that are exhibiting across the hall in the back room. There's good food and drink in both places, so please get to know some of our startups, and hopefully you'll find something that you like to invest or mentor. Thank you very much. Have a great day.